resistance, current, voltage in parallel circuit. Parallel circuit. Before we have to proceed to calculation, we have to formulate each one. Okay. Here, voltage is constant. Constant. R is different. That means it is not constant. It is not constant. The connection of R1 and R2 is parallel. Therefore, it is connected two times. This one and this one. It connects twice. If the connection of two components, if the terminals of the two components is connected or attached end by end two times, therefore the connection is parallel. Parallel. Okay. If so, what will be? Let's recombine again the formula of Ohm's law. Resistance equals to always voltage over current. That means resistance under constant temperature for a metallic conductor. It is. Therefore, let's calculate for current. I always equals to voltage over resistance. Voltage over resistance. Let it be a current flows through this direction. Through the direction in the loop. Let's take the conventional one. That means current flows from positive terminal to negative terminal conventionally. Therefore, at R1, there is I1. At R2, there is I2. Therefore, I1 at R1 is always equals to I1 at R1 is always equals to V1 over R1. But V1 is equals to V2 is equals to V because it is constant. Because its the connection is parallel circuit. Therefore, I at R1 is equals to V voltage over R1. Constant voltage over R1. But I2 at R2 is equals to V2 over R2. But V1 is equals to V2 is equals to V. It is V over R2. Therefore, I1 at R1 is always constant voltage. That means V over R1, and I2 at R2 is always equals to constant voltage over resistance 2. Therefore, let's calculate again the total current. I total is equals to current total is equals to V constant voltage over R total, which is equals to I total, which is equals to I1 plus I2. Again, V over R total, which is equals to I1 is V over R1 plus I2 is V over R2. Again. Okay. If so, let's go to next step. If we have V over R total is equals to, let's take a common as V over R total is equals to V, we can rewrite as this one as V into 1 over R1 plus 1 over R2. We can cancel, or we can divide by V times 1 over V times 1 over V. V can be cancelled by V by V. Again, 1 over R total is equals to 1 over R1 plus 1 over R2. for this is only for two resistors. For two resistors. For two resistors. What will be for the nth resistor values? Just connected for this connected in parallel. Therefore, 1 over Rn total, that means the nth resistance total is equals to 1 over R1 plus 1 over R2 plus 1 over Rn, because those are connected parallelly. In order to have the total resistance for two resistors, we can use LCM method. Here the common denominator is R1 R2 R1 or R2. That means when R1 R2 divided by R1, it becomes R2 plus R1 R2 divided by R2, it becomes R1. It becomes R1. This is for the n resistors, for n number of resistors, for two resistors. Let's put this formula to here. 1 over R total is equal to R2 plus R1 over R1 R2. Therefore, let's make a crisscross. That means R total into R1 R2 1, which is equal to R total into R2 plus R1. That means R1 R2 becomes R total into R2 plus R1, and solve for R total. And R total becomes divided by R2 plus R1 over divided by R2 plus R1. R2 plus R1 can be divided by R2 plus R1. Again, the remainder one is R total. R total for two resistors is equals to R1 R2 over R1 plus R2 for two resistors. Only, guys, this formula true for two resistors. For n resistors, the total resistance will be 1 over R1 plus 1 over R2 plus 1 over the nth resistor, because those are connected in parallel. A bunch of exercises will be attached to this one, on this one. Look at this. Hit this link. You got me? Good.